In this episode of Remote Calculus, we'll be pointing out some examples in which you should use u substitution to find your antiderivative, and examples that are kind of similar where you cannot use u substitution. That's an important part of being able to recognize how to find antiderivatives, recognizing when certain tricks work and when they do not. U substitution is a very common trick to help us simplify, but it cannot always be used. For u substitution to be available, the remaining portion of the expression has to be a constant multiple of the derivative of what you have called u. When you've substituted, you can only have u involved in some function and then multiplied by a constant multiple of its derivative. So notice here I have x squared plus 4 in the denominator. So if I recognize that x squared plus 4 is inside a denominator, I could let u be x squared plus 4. Then du is 2x dx. Notice in the numerator I have a constant multiple of x dx. I can use u substitution. Over here, I don't have the x in the numerator, so I cannot use u substitution. In Calculus 2, you'll go over the inverse trig functions. This example would fit into that category. If you had this situation, it's not a u substitution because it's just a straightforward natural log example. In this example, I have x squared inside of sine, so u would be x squared. It's the inside function. Its derivative is 2 times x dx. I have x times dx, so I have a constant multiple of du. I can use u substitution. Over here, there is no x. I don't have the outside x, and so I can't use u substitution. And in fact, this would require upper level mathematics to basically you get a numerical approximation is the best that you can do. This function here, the u is the polynomial in the denominator, x squared plus 2x plus 1. Its derivative is 2x plus 2, that quantity times dx. My numerator, notice, is 40 times 2x plus 2, so I can use u substitution. But over here, my numerator 80x squared plus 5, that's not a multiple of 2x plus 2, and neither is 3x plus 5. It's not that you just have to have the x. Here, the constant was actually part of du, and so what's here has to be the same constant multiple of 2x plus 2. 80x plus 80 was the same constant multiple, but 3x plus 5 is not. I'd have to multiply 3x by something different to get 2x, then I would have to multiply 5 to get 2. Here I have sine being squared, so sine is the u, and its derivative is cosine. So here is the du, just right there. So I definitely can do u substitution here. If I do not have that extra cosine, I cannot use u substitution. In this case, I have those trig identities, those half-angle identities, which would come in handy for us to figure out how to find the antiderivative of this example.